Hi everyone, today we are going to learn about geometric series. You might have heard of something called exponential growth, like a rumor spreading through a school or a viral video getting shared online. Each person tells two friends, and then each of those friends tells two more. The numbers can get very large very quickly. This pattern of repeated multiplication is at the heart of what we call a geometric series. First, let's make sure we are clear on the building block, which is a geometric sequence. A geometric sequence is just a list of numbers, where you get from one term to the next by multiplying by the same value every time. That multiplier is called the common ratio, and we usually denote it with the letter R. For example, in the sequence 3, 6, 12, 24, you multiply by 2 each time. So the first term, which we call A, is 3, and the common ratio R is 2. A geometric series is simply the sum of the terms in a geometric sequence. So if our sequence is 3, 6, 12, 24, then the corresponding series is 3 plus 6 plus 12 plus 24. Adding them up term by term is fine for a short series. But what if you had to add the first 20 terms, or the first 100? Doing that one by one would be incredibly tedious. This is why we have a beautiful and powerful formula to find the sum directly. The formula for the sum of the first n terms of a geometric series, which we write as S sub n, is this. S sub n equals A times the quantity 1 minus r to the power of n, all divided by the quantity 1 minus r. This formula works for any common ratio r that is not equal to 1. It's crucial to remember the structure. The first term A multiplied by 1 minus the common ratio raised to the number of terms, all over 1 minus the common ratio. Let's test it with our simple example. We want the sum of the first 4 terms. A is 3, r is 2, and n is 4. Plugging into the formula, we get S sub 4 equals 3 times the quantity 1 minus 2 to the power of 4, all divided by 1 minus 2. That's 3 times 1 minus 16, all divided by negative 1. 1 minus 16 is negative 15, so we have 3 times negative 15, which is negative 45. And then divided by negative 1 gives us positive 45. Let's check by adding. 3 plus 6 is 9, plus 12 is 21, plus 24 is 45. Perfect. The formula works. Now let's try a more typical IB style problem. Suppose you are asked to find the sum of the geometric series 8 minus 4 plus 2 minus 1 plus, and so on, up to the first 7 terms. The first thing to do is identify the parameters. The first term A is clearly 8. To find the common ratio R, we take the second term and divide it by the first term. So negative 4 divided by 8 gives us negative 0. Always use the second term divided by the first to be safe. We want the sum of the first 7 terms, so n equals 7. Now we apply our sum formula. S sub 7 equals 8 times the quantity 1 minus, open parentheses, negative 0. 5, close parentheses, raised to the power of 7, all divided by 1 minus, open parentheses, negative 0. 5, close parentheses. We need to be very careful with the negative sign inside the parentheses. First, calculate negative 0. 5 to the 7th power. Because the exponent is odd, the result will be negative. Negative 0. 5 squared is 0. 25 to the 4th power is 0. 0.0625. So to the 7th is negative 0. 0.078,125. But it's often easier to keep it as a fraction. Negative 0. 5 is negative 1/2. So, negative 1/2 to the 7th power is negative 1 over 128. Because 2 to the 7th power is 128. So inside the parentheses we have 1 minus negative 1 over 128. 1 minus a negative is 1 plus. So that becomes 1 plus 1 over 128, which is 129 over 128. The denominator is 1 minus negative 0. 5, which is 1 plus 0. 5, or 1. 5, which is 3 halves. So now we have S sub 7 equals 8 times 129 over 128, all divided by 3 halves. Dividing by a fraction is the same as multiplying by its reciprocal. So this becomes 8 times 129 over 128 times 2 over 3. We can simplify before multiplying. The 8 and the 128 share a factor. 8 goes into 128 16 times. So 8 over 128 simplifies to 1 over 16. Now we have 1 over 16 times 129 times 2 over 3. The 2 and the 16 can simplify. 2 over 16 is 1 over 8. So we have 129 times 1 over 8 times 1 over 3. That is 129 over 24. We can simplify this fraction by dividing numerator and denominator by 3. 129 divided by 3 is 43. And 24 divided by 3 is 8. So the sum of the first 7 terms is 43 over 8, or 5. 375. A very common mistake is misidentifying the common ratio. Students sometimes subtract terms instead of dividing. Remember, you find R by taking any term and dividing it by the previous term. Another frequent error is mishandling the negative signs in the formula, especially when raising a negative r to a high power. Always use parentheses. Also, a conceptual mistake is using this finite sum formula when you are asked about an infinite sum, which is a different concept entirely for when the magnitude of R is less than 1. To wrap up, a geometric series is the sum of terms in a geometric sequence, where each term is found by multiplying the previous one by a constant ratio. The formula for the sum of the first n terms is a lifesaver. The first term times 1 minus the common ratio to the nth power, all over 1 minus the ratio. It allows us to quickly find sums that would be impractical to calculate by hand. Remember to carefully identify a, r, and n, and handle the algebra with patience, especially when r is negative or a fraction. This tool is incredibly powerful for modeling real-world situations involving repeated percentage changes or multiplicative growth.